Hey everybody, and welcome to Science. We are in Lesson 2, Part 2, and we're talking about forces and motion. Now, when we're talking about forces in this lesson, we're talking about balanced versus unbalanced. So if we remember, balanced means that there's an equal force on both sides, pushing right now, or pulling, and neither one is giving more force. Now, if you give one with more force, that means that it has more newtons of force, because we measure force in newtons. And when there's an unbalanced force, there's movement that occurs. So I can see that this is moving because my one arm is giving more force. Now, if you're pulling, it's the same thing, pulling force versus the other one. So it moves when it's unbalanced and it does not move when it's balanced. So let's go back into the reading that we checked out yesterday and just cover it. This picture shows a game of tug of war. Both teams are pulling the rope. As you can see, the arrows are the same size, which means they have an equal force of pulling, but in the opposite direction. Therefore, we can assume that nobody is winning this game, and that the teams remained in the same place. Balanced forces are two forces equal in size, acting in opposite directions on the same object. When the forces on the object are balanced, the object does not move or stays moving at a constant speed. When the book lies on a table, the forces on it are balanced. Gravity pulls down on it, but the table pushes up on the book. So that brings us to unbalanced. Here's a picture. Isaac Newton described in his first law of motion that if the forces are balanced, an object will remain at rest. If the forces are unbalanced, the motion will occur. In this second picture, the force arrows show that the teams are pulling in opposite directions. Forces are measured in newtons. The blue team is pulling at a force of 9 newtons, whereas the red team is pulling in a force of 4 newtons. The equal forces are unbalanced. Therefore, motion will occur. In this scenario, the blue team would pull the red team forward because their force is stronger. However, this is not simply because there's two of them. If we had an adult versus two toddlers, the adult would most likely win and generate more power because the toddlers do not have as strong of a force. So let's go on to questions 3, 4, and 5. So question 3, it says, are two people always stronger than one? Well, anybody here that watches like WWE wrestling would say no, two forces are not always stronger than one, because you could have two little people that are not as strong as somebody who might work out a lot and is very large. So are two people always stronger than one? No. People have different strengths and sizes. So when we think about different strengths and sizes, we're saying for real that two people that don't work out might be weaker or have less force than somebody who is working out. So that one person could be stronger than both of those other people. And then you can think about size like they had in that example. You could have one adult who is stronger and bigger than two toddlers. So that brings us to kicking a soccer ball into a goal is an example of a balanced or an unbalanced force. So think of the soccer ball as the object. The soccer ball is sitting on the grass and you kick it. Is it unbalanced or balanced? This is unbalanced because the ball moves. Hanging your coat on the peg in school to hang it up on the wall. Is this an example of balanced or unbalanced? So look at your coat hanging on a hook. What's happening? This is balanced. And this is balanced because the coat is not moving. And to describe that, motion, or that lack of motion, is to say that the coat is getting pulled down by gravity, but the hook is pushing up. So it's a balanced force, which is why the coat stays still on the hook. So we're going to watch a video right now, and this video is Science of Forces. It's only a few minutes long, and we'll watch that in full screen on my screen. And then if it's glitchy for you, you can always watch it on your screen in your slideshow. So here we go. Hopefully it works for you. I'm Dr. Jeff Vinegar, and today we'll explore the science behind balanced and unbalanced forces. All right, so that brings us, guys, to the next slide. We're going to go to balanced or unbalanced on this slide. And it says, drag and sort each scenario under an example of balanced or unbalanced. So I'll read these out loud, and then you're going to be moving them to balanced or unbalanced. Now remember, balanced means they are not moving. Unbalanced means they are moving. So let's get ready to organize. It's my second reference to wrestling today. My son started watching WWE recently. We only watched 2 episodes so far, so we'll see. Maybe it's something he'll watch more of. I don't know. The book sitting on a desk. A skier coming down a mountain. A parachuter falling to the ground. A car accelerating at a starting line. A train moving at a constant speed. An apple hanging from a tree. A soccer ball on the grass. And a tennis ball being hit by a bat. So I'm going to move these, and you want to check your answer. I have purple in balanced. I have pink in unbalanced. I have orange in unbalanced. I have the car unbalanced. I have a train unbalanced. Oh, constant speed. Tricky one. It's moving, but it's not changing speed. So it's balanced. An apple hanging from a tree. Balanced. A soccer ball in the grass, balanced. A tennis ball being hit by a bat, unbalanced. So let's talk real quick about this one. So we look at the balance and we see that all these items are just sitting still. They're not moving. So you would say that they are balanced because they're not moving. There's an equal force acting on both of them. So it's like my hands like this. Now, let's say that my hands are like this and I can cause motion to happen. Now, you would have to say, is my motion that's happening right now a constant speed? No, this is not constant because one, it keeps going one way then the other, but then also I could be speeding up and slowing down the whole entire time. Now, a train traveling at a constant speed, it has a balanced force because it's not slowing down or speeding up. So when you start moving something, that's an unbalanced force. When you are accelerating or moving faster, that's a unbalanced force. When you're moving slower or stopping, that's an unbalanced force. But when you're moving at the same speed, which could be 0, or it could be 10 miles an hour, or it could be 1,000 miles an hour, if you're moving at the same exact speed at all times, that's a balanced force. So a balanced force just means that you're not changing your speed, whether it be 0 and you're still moving at 0, or you're moving at 100 and you're still moving at 100. So that's balanced. So a tricky one, that green one. Let's move on. I'm just going to fix these so tomorrow I'll be like, everybody will be like, Mr. Hester, you left all the answers there. I'll be like, no, why? Why? All right, moving on. Reflection. This is for you guys to reflect. So what have you learned in lesson 2? So this is yesterday and today. Who will win this game of tug of war? Explain your answer using scientific reasoning. So you shouldn't talk about their color of their team. You shouldn't talk about them being boys or girls. You shouldn't talk about their sizes. You should only be talking about the arrows and how long the arrows are and what direction the arrows are moving. And once you have that done, you have finished. So make sure you say which team you think is going to win and why. Once you're finished with that, click turn in. You're finished your science. Palm it.